So this work is the result of a couple of years of work. Tyler's been here from the beginning, but everyone has played a role over the years, these students who've done this research with me. Next slide, please. Okay, so we know that climate events and extreme weather events are increasing in frequency and severity. You can see a few events, catastrophic events here just from the last year, often dovetailing with one another and, really stretching our resources across the country. Next slide, please. In light of this, that plus the affordable housing crisis, we know that we need housing, we need affordable housing for everyone, but we need it to be safe and to be comfortable for everyone. Recognizing that not everyone feels the impacts in the same way. So for instance, older adults are more susceptible to heat. And also location-wise, not everyone is at the same risk, with First Nation communities disproportionately at risk, with 81% of reserves exposed to flooding alone, given the colonial history. So given all of this, it's more and more important to think about how do we adapt and how can we adapt in place when we're constrained, right, by not being able to move necessarily. Next slide, please. So what we've come up with is a website with a database that we'll go through to help people wrap their head around what are climate resilient retrofits for adaptation. When we started this work, resilient retrofits referred to energy efficient retrofits, but we're talking about resilience that tackles adaptation and doing things in a way that also do not exacerbate climate change by increasing energy use or greenhouse gas emissions. So we've got a website there for you to check out, and we'll go through what you can find there in terms of the database, especially when it comes to these 5 hazards that we list below. Next slide, please. So quickly, the evolution of this work. Back in 2022, Halifax Regional Municipality came to us saying they're facing all kinds of hazards all at once. They've got assets at a municipal level, local governments across Turtle Island have assets that they have to manage. Plus, they're trying to figure out how to keep their citizens safe as well. But they were faced with all kinds of information in different places, infographics here, hazard-specific brochures over there. It was very hard to figure out what does everything mean altogether. So we developed an initial database. National Research Council came in a year later and helped us to further refine and develop it with more criteria that you'll learn about, where you can make better decisions for your specific circumstances. And then, just so you know, this work is being fed into climateinsight.ca, which is a project of ICLEI and funded by Housing, Infrastructure and Communities Canada. So this is the trajectory of the work, and we're just grateful for all of our partners that have come alongside with us. Next slide, please. Speaking of which, I'll hand things over to our collaborator, Alex Hayes.
Well, thank you so much, Sharmalene. And that was a great way to introduce the kind of overarching project here at NRC. Now, I know we stepped in with Partners for Action while they were already underway, but there was good reason for that, is because we saw an opportunity to build on the work that they were doing and incorporate it into our bigger picture of what we were seeing. So the project team here at NRC is Marzia Riahinazad, myself, and Adam Wills. working together on these resilient residential retrofits project. This is not, it's a under the theme of CRBE, so Climate Resilient Built Environment Initiatives, which is 2021 to 2026. And this is building off of a partnership with Infrastructure Canada from 2016 to 2021. Now, the overarching objectives of the project, or well, our cubed project, is to successfully demonstrate projects and de-risk recommended resilient retrofit measures. So once we figured out strategies to de-risk, or that should be decreasing vulnerability, we would like to de-risk them by doing pilot studies. And we'd like to strengthen our partnerships and our collaborations across Canada. And we'd like to then finally share this information from what resiliency means across the country under different guides and standards. The four primary climate hazards that we were looking at are wildfires, extreme heat, flooding, and extreme winds. But there's also the sub-hazards that we need to understand that go along with these main hazards, such as smoke and permafrost melt, along with a handful of others. Now, the objective of the actual project that I'm working on are to find and de-risk resilient, sustainable, accessible, and affordable retrofit measures. And we want to prioritize them using a multi-hazard lens. So what to do when you have competing hazards in one area. We want to pre-qualify these technologies using our CCHT, or the Canadian Centre for Housing Technologies. So if you have some good strategies that decrease your vulnerability, we'd like to try them out and see firsthand how they work. And then we want to integrate them into guidances as well. So the overall project that we are working on is trying to think of how all the players, as Sharmalene was mentioning, interact with each other. How does all this information that's bombarding us, how can we make use of that? So we proposed this kind of adaptation flowchart or roadmap, and it starts on the top left for hazard exposure mapping, and it goes all the way down to the bottom right of knowledge dissemination. So once you understand the exposure that's in your area or the climate loads that are happening now or in the future for your area, you have a better sense of what to prepare for. You then have people come in to help, or team members help identify what vulnerability means to your buildings against those exposures and those hazards and those loads, and what vulnerability means to the occupants. The demographics in each household might not be the same. Therefore, your vulnerability might not be the same home to home. Then you need to understand what the combined risk might be. Once you've understood the risk that's enacting on your occupants or your homes, you can start to figure out what adaptation strategies might be used to decrease your vulnerability. This is where the database from P4A comes in, and you might be presented with a whole bunch of different strategies. From there, you'd assess these strategies for return on investment, cost benefit analysis, energy and GHG savings, and emissions savings. We can de-risk some of these these technologies before suggesting them to go into homes, and then make best practices and guidelines for how to actually implement these in our homes. I'd like to work through a quick example. I know I don't have a ton of time, but I want to go through this. In 2021, the heat dome in BC was very bad. 619 people unfortunately lost their lives. 90% were over the age of 60, 67% were over the age of 70. 98% of the deaths occurred indoors where they were supposed to be protected from these extreme elements, and 56% lived alone, and 61% were located in low-income neighborhoods, unfortunately. Hence why we're trying to find sustainable and affordable and resilient strategies going forward. Now, if you were faced, let's say, with multiple hazards at the same time, you might learn that you are exposed to both the heat vulnerability and smoke vulnerability during a summer period. You might have an assessment done using, say, some of the tools like from the Institute of Catastrophic Loss Reduction to determine your vulnerability or your risk for your building and your occupants. You might make use of tools such as the tools from the Canadian Housing or Canadian Mortgage and Housing Corporation for resiliency, or practices from the Canadian Home Builders Association, Health Canada vulnerability warnings, and public safety flood warnings. You might be able to model some of these and determine how warm your house might get during a summer period. Once you've determined that your home is vulnerable, and you might want to start looking at different adaptation strategies, where you might turn to a database such as Partners for Action at climateresilientretrofits.ca and find a whole bunch of amazing solutions to decrease your vulnerability. You then might learn from their website that there's certain conflicting strategies where you don't want to have a strategy that benefits you, say, in overheating, but causes maladaptation for wildfire smoke. You'll find strategies that are complementary to each other, whereas air tightness helps in both cases. And you might find strategies that are coordinated. So if you're already doing this, you might as well do that to improve your conditions. You then might start assessing them in terms of how does it meet the energy demands? Does it actually save us energy? Is this going to have cost benefit analysis for us? What is the client's budget? Is this something that we can afford? And will it help us with both our operational and our embodied carbon savings? And are there grants out there that can help decrease, the upfront cost of some of these solutions? However, we do realize that it might be an iterative approach. And whereas it might not meet, say, the client's budget, you'd find other adaptation strategies, such as, coordinated personal strategies or coordinated community level practices to help decrease your vulnerability. And from there, you'd be presented with, say, a strategy or roadmap on how to decrease your vulnerability to those multi-hazards. Thank you very much for your time.
Hi, can everyone see my screen?
Yes.
Okay. So now for the database overview. So my fellow researcher Tyler and I will be presenting on some of the fundamental steps we took to develop and structure this database. So once again, the database is located at climateresilientretrofits.ca, along with some additional resources from Partners for Action and other organizations for building climate resiliency within communities. So from the very beginning, we wanted to create a tool that recognized the threat of climate hazards that are happening all over Canada. We asked ourselves questions about what were the most prevalent climate hazards that buildings need to adapt to today. So through our extensive research, we really were able to identify 5 major climate hazards that probably most of you are aware of. And these being floods, extreme heat, extreme wind, ice and snow, and lastly, wildfire. So these 5 hazards are actively causing havoc in different regions across Canada every single year, causing millions of dollars in insured and uninsured losses. So some regions might even face some of these hazards simultaneously. For example, British Columbia is one of those regions. So 3 years ago, when we first started this work, we recognized that there was no really existing framework to organize, structure, and compare the various impacts and solutions for these climate hazards. So we asked ourselves key questions to kind of help guide the development of this database. So we asked ourselves, how do these hazards affect our existing buildings? What will help reduce risk for buildings and their inhabitants against multiple hazards? And lastly, how do measures or retrofit strategies for one or more hazard actually relate to each other? So our extensive research helped answer these key questions, and a critical part of this development was the introduction of what we call adaptation objectives, which is what we determined to be the fundamental science, method, or strategy the retrofit aims to achieve to reduce the risks and impacts of the climate hazard. So the purpose of introducing this parameter is to ensure that as future technologies and solutions appear, they can be quickly integrated into our existing database as long as they share the same fundamental adaptation objective, regardless of differences in building type, occupancy, or even location. So what does our database actually look like for the average user? So here we actually have a screenshot. So our database lists the retrofits available for all 5 climate hazards. Here we see only extreme heat, but as you scroll down, the other hazards will appear. And the database provides tags and filters that allow the user to sort, organize, and prioritize the ones that matter to them the most. Because as we recognize, people are facing different problems across different regions. As you can see here, on the next page, if you slide over, you can see that each option has an arrangement of information provided with different parameters and ratings to help the user gain a preliminary understanding of the retrofit strategy. So the goal of this database is really to create a repository of different critical information that can give users a place to start uh, looking for ways to build climate resiliency immediately. So our users can include policymakers, contractors, and researchers, to name a few. So climate change affects all of us, which means anyone who wants to change their buildings and become more climate resilient can use our database. So the database is not really the final solution, but is meant to be built upon by others as well. So organizations such as LEAP and Climate Insight have already begun using this tool. We've also begun integrating our database, as you said, with ICLEI and other websites. So since our end user could widely vary, their priorities may shift as well, based on the role and circumstances that they face. So this is why we introduce ratings into our database to help inform users if the retrofit is feasible based on parameters such as cost, time, and complexity. So additionally, we also consider invasiveness and preliminary effects of the retrofit on energy use and carbon emissions. So these ratings are based on general scale of increasing value. So cost is something that every user will care about. For this, we consider 3 cost ranges, as you can see here. But if the user is a planner, for example, maybe they might be concerned about time. So here we consider the amount of logistical planning and effort needed to put the retrofit strategy into action. In another scenario, the user might be a contractor. Maybe they're concerned about the complexity or skills required. So the user could also be a homeowner who's considering completing the retrofit themselves. This information describes the level of knowledge needed to safely, efficiently, and accurately integrate the retrofit. Similarly, if the user is simply a resident within a building, they may want to consider the possible disruptions to their lives. So some projects can cause major disruptions, whereas others might not affect people at all. Lastly, for each retrofit, the database also generally considers energy use and the possible emissions caused or mitigated. We wanted people to consider the fundamental sustainability implications of different projects. With so many different possible retrofits across the 5 climate hazards, we want to investigate the relationships between them. So to do this, we consider the conflicting, coordinating, and complementary relationships, as Alex mentioned previously. So when two measures work against or diminish the benefits of each other, they are considered conflicting. If the measure addresses multiple hazards at the same time or increase the benefit of another measure, they are considered complementary. Lastly, if a measure should be considered alongside another measure for practicality or convenience reasons, we perhaps to, for example, save time or cost, they fall under the coordinating category. Oh, so here we have an example. So for example, you can plant vegetation as a strategy for extreme heat. So a user can mitigate the impacts of extreme heat by planting vegetation to provide shade. So the ratings of this retrofit is listed in our database while outlining the conflicting, complementary, and coordinated relationships with other hazards. So here we can see that it clearly conflicts with removing vegetation for wildfires, whereas it is complementary for planting rain gardens to help with flooding. Additionally, it is practical to consider removing stones around the building while planting vegetation to reduce the impact of extreme winds on a building. So this retrofit strategy is easy to implement as indicated by the ratings provided. It has a relatively low cost with little planning or expertise really needed. Generally, this retrofit will not cause major disruptions, and it will also provide some carbon benefit and potential energy savings. Now, the user can investigate one of the conflicting measures previously discussed, clearing vegetation, specifically within 1.5 meters of the building. So clearing vegetation helps with mitigating risk for wildfire, but has a conflicting relationship with planting vegetation, as previously mentioned. However, if you choose to clear vegetation instead, this can be complementary for removing branches around the building for ice and snow. Additionally, while clearing vegetation, you may want to consider removing trellises, which also help with reducing the risk for wildfires, as shown by the coordinated relationship. Like planting vegetation, this retrofit strategy is generally low cost and requires no expertise. However, some planning is required, even though it will generally cause no disruptions, and you're removing carbon sinks. This is just one example of the complex relationships different retrofit strategies may have. So this is what the database actually looks like if you were to click it on our website. While building this database, we wanted to focus on the key parameters that people really care about to help them navigate this new multi-hazard climate reality. By exploring the database and looking at the different measures and their relationships, users can really familiarize themselves with the different retrofit strategies commonly used across Canada. Now Tyler will present another user case scenario.
Yeah, thanks, Harry. So we wanted to run through here a little application of the database for our scenario. So the one we wanted to look at here was if an Indigenous government is planning to retrofit homes with a new insulation for energy efficiency, which climate resilient measures could be incorporated at the same time to maximize the total benefit of the program? Yep. So going into what the database looks like, one way we can look at this further is we could use the search function and search for where insulation comes up. So with that, we see that we can also look at implementing airtight insulation for this. And if we click near the airtight insulation, it brings up the card that Harry showed previously. So on this card, we can see that typically this is involved with the walls of the building. Wildfire is the main hazard that it's dealing with, and the problems or impacts that we saw from wildfire before was the smoke as well as potentially the occupant health. And overall, our objective is to maintain or improve that air quality inside if we weren't putting this retrofit in place. So further on the card, as we bring this up, we can scroll down and see some of our complementary and coordinated measures. So other things that might complement this are sealing air leaks and adding insulation. So that's going to help us with our extreme heat as well and keeping that hot air out and helping regulate the temperature on the inside of our building. And we even see things here for ice and snow as well. As if we make the ceilings airtight, this can help with ice dams forming on the eaves troughs of our homes in the winter. If we look down to the coordinated, so if you remember back, this is things that could potentially be done at the same time to create some efficiency when installing these retrofits. We see some different ones here, like if we're dealing with the walls of our building, potentially adding reflective surfaces helps reflect the heat gain away from our building. We see other things if we're exposing our walls to add insulation. There's a number of extreme wind or EW retrofits on the bottom, which we can work in the structure of our walls while it's exposed and we're about to add insulation to it. Is a good opportunity to go in and do these more structural retrofits. Yep, you can go next, Terry. Further down on the card, you'll see some of our rating systems that we have for this. So adding airtight insulation is our highest cost rating, requires a decent amount on the time and effort. It's pretty expertise required. I can't just go do this on a weekend, and it's fairly invasive a lot of times, either removing interior finishes or exterior finishes on the building to get in there and add insulation. Going down, you also see some other tags. We have a physical retrofit. We're physically doing something to the building in this case. There's some other ones which are more behavioral. Cleaning out eaves troughs would be an example of that. We see implementation, so we want to be proactive with this one before an event, and as well as some different building archetypes that this could be applicable to. This is an example applicable across a variety of uses, so you see all our building types there. And we even have some references if those enacting these want to know more and get more into the weeds of these solutions. You can see some of the key references we use to fill out this card. Yeah. So overall, our database, we try to synthesize this vast amount of information out there in multiple different resources and organizations into a common place that's more easily digestible to our stakeholders to figure out, based on their hazards of concern, what do I need to do? We also tried to organize this with key parameters and sortable functions to be able to allow users to know what to do and why behind it. And as well as connecting these retrofits with the 3 C's to understand, by doing one thing, how am I potentially improving or making worse my resilience to another hazard. So with that, coming to the end here, we just wanted to acknowledge our funding partners on this, the original with Halifax Regional Municipality, and then finishing this database with the Natural Research Council of Canada. And we really want to say special thanks to the reviewers that gave us additional review on this database, especially Alex here on the call, who has been very helpful along the way and pushing this to the finish line and getting it up for everybody to use. Yeah. So I think Aaron put it in the chat as well, but there's the link to the website where the database can be found. You can reach out to the team as well with any questions or things along the way or feedback you might have found for the database while using it. All right. Yeah, thank everyone for their time, and I think we're into Q&A now.